All right, here we're going to look at example 4, where we simplify nth roots. I'll be very honest, a lot of students greatly dislike these type of problems, but the good news is that the examples that we're going to cover in this section, for at least now, they're going to work out very nicely. We're not going to have to worry about any of the extended rules. Later on, and I'll point it out as I'm doing the problem, there will be some things that you have to do slightly differently, but this method will be applied, for us for now. And as the problems get more complex, you'll just have to add in an extra step. You'll have to make some kind of slight changes. All right, so part A, simplify each expression. We have the fifth root of 32m to the 15th. I'm going to show you the math going on in the background and then show you what you could do to kind of make this problem a little bit easier for yourself. So we have the fifth root, and I'm going to rewrite 32. I know that that is 2 to the 5th power. And m to the 15th, I'm going to try and make that m to the 5th power as well, which is m cubed to the 5th power. And I know that seems silly. It's like, oh, where is that number coming from? Basically, what I'm doing is taking this 15 and dividing it by the 5 on the outside. All right, divide by your index. So these 5s here, 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 this one effectively cancels these inside ones out. So what's going to happen is that the fifth root of 2 to the 5th is 2, and the fifth root of m cubed to the 5th is m cubed. That's a terrible 3. So this would be your answer. Now, I probably wouldn't write it like that all the time, and I wouldn't really use that kind of process. What I would suggest you do is if you have this problem, you have 32 and m to the 15th, 32 you'll start to learn is the fifth root of 32 is 2. So we can automatically kind of know that that 32 is going to come outside as a 2. And then what you're going to do is you're going to divide these numbers. All right, you're going to divide inside by the outside. So 15 divided by 5 is 3. And that's where we're going to get our answer from. All right, like I said, these numbers for the example in the section we're covering now, these numbers are going to be divisible. Later on, you will get problems like the fifth root of, let's say, x to the 16th power, where 16 is not divisible by 5, but you'll learn what to do with that. Right now, don't worry about that. Okay, don't stress yourself out for no reason. So in part B, it's a little smaller, so I'm going to rewrite it. We have the fourth root of x to the 20th, y to the 8th, and same idea. I'm going to divide these. All right, I'm going to put that in 2 different colors. So 20 divided by 4 would give me x to the 5th, and 8 divided by 4 is going to give me y squared. So when I divide those, I got that 5 and that 2, and that will be my solution. So just remember to divide the inside number by the outside number. Made a mistake here, or not a mistake. There is something we need to add to this. Sorry, I forgot. Completely forgot. It's a very important rule. If you are taking an even root, so let's go back. Let me get rid of this highlighting. All right, this rule that I'm about to explain doesn't apply to part A because it was an odd root. All right, this 5 is an odd number, so we don't care about it. However, here we have a fourth root of a problem. All right, 4 is an even number. So when we take the fourth root, we do need to put our answer in absolute value brackets. All right, we just have to make sure that we have the positive roots. So it's very important that you do put those in the absolute value brackets. Now, what you can do with those absolute values is simplify a little bit further. X to the 5th could be positive or negative. So I need to kind of leave that alone. However, y squared is always going to be positive. So I can actually take out that y squared out of the absolute value. This is probably one of my least favorite rules in math. People forget about it all the time. Clearly, I just forgot about it while I was explaining this problem. I don't want to say it's easy to understand, but once you start to get it, it is pretty straightforward. It deals when you have an even root. So let me do some highlighting. Anytime you have an even root, you're going to need absolute values. And then any even powers inside those absolute values, in this case, this 2, that's even, so that 2 can come outside of the absolute values. The 5 is odd, so that's going to need to remain inside the absolute values. If you really want to understand why this is all the case, it really just comes down to having positive roots. If you don't care about the why, just learn the process and you'll be okay. But once again, it's if you have an even root, this 4 here, one more time, you're going to need absolute values. So even if it was a square root or a 6th root, you're going to need absolute values, okay, whatever number is on inside here. And then once you have that absolute value inside, you will need to keep any odd exponents inside, the x to the 5th in this case, and the y squared, since y squared will always be positive, you can take it outside of the absolute value. Again, sorry about that. I don't make the rules, but this rule needs to be in place, so be careful with that.